Cool. All right, so we're still in Module 1. I said in the announcement that we were going to get through Module 1 all the way to Module 2. I'm not too worried about getting through Module 2 because I want to take some time with this, and Module 2 is going to be fairly quick. The end of Module 1 actually is, I really feel, is a minor consequence. So if you guys want to do the end on your own, I don't think there's anything accessible at the end of Module 1. I should probably double check before I open my mouth. Let's do this. All right. We're going to probably end here with 1.44 intranets and extranets. Internet connections. Uh, I might put together a small video for it, but I'm not going to make it's literally talking about the types of connections that come into the networks. We're going to be serving and servicing and maintaining the networks. I'm not too crazy caught up on this. I don't even know why we have this. The only thing that's really of note is converging networks, and in all honesty, I can give it to you guys in 5 seconds. Old networks used to look like we have a device, it's connected to another network device, and there we go. We have a network, and that's how we make stuff happen. Now, our devices, our hosts, our roles, all of this is everywhere. You might have heard of the term platform as a service, software as a service. I mean, like you don't watch YouTube or you don't watch videos from your home. Well, I still do, but I'm a nerd. From your home video like Plex server, you go to Netflix, right? So the resources you're trying to connect over your network are typically served to you from outside of your internal network through the internet. That's the only thing that converging network really has to talk about. Network architecture, we'll get into that. Never mind, as I was. But anyway, enough of that. Let's get into what we're supposed to be talking about today. We're going to spend some time with it, not too much, and we're going to have some fun. Um, I got to stretch. I've been sitting down for too long. You guys want to stretch? You can do it with me. I'm going to do some arm rolls. I'm going to do some shoulder rolls. I'm going to do some samba. Look, Jesse's getting it. Oh, I got to do one of these. I got to do one of these. I'm going to do some kicks. I
I've been
pulled some.
sitting. I've been sitting down all day.
Dude, it's rough. It's rough. Plus, I feel like that's the only way. Just moving around is the only way to get some energy out, get some stuff going. Okay, so who can give me a reminder of what we talked about last week? I think I mentioned this to the other class, but go ahead and give me a quick play by play. All right, I'm gonna do what I did in the other class. Professor J, I remember we talked about endpoints, which are also known as hosts. And there's these devices on the network. They're called intermediary devices, and they like handle traffic. I'm not sure how, but I know it's gonna be cool. And by the way, you're a cool ass dude, and I really like hanging out with you and stuff. Excellent. That's pretty good. You guys got almost everything. So we've got
Yep.
these things called hosts on the network, right? Their job is to somehow communicate within the network, share information, and be members, participants of a connected system. That's what a network is. We sometimes call them endpoints, but from here on out, we're probably just going to call them hosts. It's going to make it a little easier to do. We also know that hosts have to be identifiable on the network. Brandon, I can see your face. I love it, dude. Um, so the hosts have an identity. Typically on a network, we use what's called an IP address. I know it doesn't mean anything for you right now, but it's a unique address, much like your street address is for your home. And IP stands for Internet Protocol. There's a whole, I mean, we can spend an entire week on what Internet Protocol really means, but I just want you to know an address right now. Computers also have something else, or excuse me, hosts also have something else. They have what's called host names. They're colloquialisms. They're what we also know as resolved names. So instead of saying my Surface tablet here is IP address 10.220.5.17, it's also called J's Surface. If I were to look for J's Surface on my network, I would find it. If I were to look for Jay's surface on the internet, there would be no way for it to know where the hell to go. So we've got these endpoints, these hosts, they're connected via this fascia, via this connective tissue somehow. We'll call that a network as a whole. And then we have these addresses, ways that we can look at our our devices. So let's talk a little bit about the orientation of a network. First, we also talked about servers versus clients. Remember, guys? So a server offers up information, clients request information, and we talked about sometimes and oftentimes a host can be both a server and a client. But in some of our enterprise roles, a server is traditionally a server. It only offers up resources, and our client hosts are typically client hosts. They only request resources. The greedy bastards. Anyway, so we've got this client server relationship, and we talked about how those things that work. There's different ways that we can have a server client relationship. So one is that, we have one server. This is the server, and we have these hosts, and they request information from this one point through whatever pipeline that we've architected, right? We've got this other concept, and it's called peer-to-peer. Now, we don't see this frequently, especially in higher end environments, but it is possible for you to create a resource on a network and just have it sitting attached to your computer, right? So here we go. Here's printer 01, here's scanner 01, here's copier 01. Imagine this is the network, right? And these computers are attached to the network. Whoop. Rich not in the house. All right. So a we already talked about a single host can be both a client and a server. In this situation, a host can be a server, but not to its own resource, but a resource that's attached to it. So this is a distinction between a traditional network topology. It's called peer-to-peer. These guys are not like these guys who are going here for resources. These guys are sharing resources with each other. Um, if you're looking at peer-to-peer and accessing resources, I like to say, think of it as going for a network asset via another host, right? So if I'm a host, I'm going to look for an asset via another host. All right, I got an exercise for you guys. I think you got it though. I'm feeling pretty good about it. If let's say my computer works. Let's say I got laptop one and I now connect on the network. What host does laptop one need to connect to use, let's say copier 01? How's that going to look like? What's that relationship going to look like?
You need to connect to PC05.
Yeah, that's right, PCO5. All right, how about printer 01?
PC01.
Exactly. So we're no longer doing this example or this relationship where we're getting resources directly from the asset. We need to go via another host in order to access this asset. It's got some, we'll go on the next one. It's got some advantages and it's got some disadvantages. I'm going to tell you right now, if we're doing our jobs the right way and we're in uh, I don't want to say a bougie environment, but an environment that has the dollars to spend to do things the right way, we'll probably never use a peer-to-peer environment. But we should know about it in case we need to do it. So some advantages, super easy to set up. Obviously, they're not complex. Lower cost because you don't need network equipment anymore. I mean, now you can actually connect these computers directly into, well, we'll learn about it soon, but what's called a switch. And they're it's a simple task oriented deal, right? It's not like we're looking for authentication, crazy security and stuff like that. We're just doing stuff that computers can do by proxy of their nature. All right. So The disadvantages, though, of course, there's no centralized administration. Like, if Susie gets pissed off in the copy room and she doesn't want you to print from her machine anymore, she can just unplug her USB page. Like, damn it, Susie! I was in the middle of my TPS report. I'm on page 7 of 12. Now what am I going to do? Susie's like, I'm sorry. You shouldn't drink all the coffee in the copy room. This is a strangely specific example. But, Susie, if you're listening to this, you know who you are. Okay. It's not scalable, right? You're pretty much locked in with the devices that you have, and it's just not feasible to get larger than that. And then all devices are now acting as both the role of client and server, so now their performance is degraded. So it's cheap and easy. There's a pro. But a con is, it's just not feasible for an enterprise environment. Everything that we're doing from this point on is going to be stepping off from the peer-to-peer as a host, moving peer-to-peer, and looking at how we can do and create and architect robust network environments. So I got a question for you guys. What happens, or what needs to happen, I should say, if you connect to a device via another host? So let's say your laptop one, and all you know is that you need to get to printer one. What do you need? What needs to happen? I'll give you a hint. It's not a straight shot to
Yeah.
print. Go ahead. I'm listening. Sorry.
Connect to the network via Wi-Fi or
Right? You got to connect to the network. All right. So that gets you. We'll just call this on this main bus here. That gets you on the main bus. But you can't. If this were directly connected to the bus, to this main drag here, we could just say, all right, give me printer one. But now we can't do that. That's right.
PCO1 needs to share printer one.
Exactly. PCO1 needs to share printer one. You need to have knowledge of PCO1, and also PCO1 needs to be on, needs to be communicative, and it needs to be available. So there's a lot of stuff going on in the background. So in short, peer-to-peer sucks. All right, moving on from peer-to-peer. We're going to go back and we're going to talk about end devices a little bit more, but we're going to give an idea, some more meat to this intermediary device concept. So we talked earlier about unique addresses. Don't want to get too into it, but all right, cool. So in order for hosts to communicate among a more robust network, not this peer-to-peer thing, we've got a few things that we need to do. First of all, we need to know who I am, right? That's that IP address thing. IP addresses are typically given out from organizational maintainers that have roles within the network. So that could be a server. You'll hear this later. We'll talk about this in depth, but it's called a DHCP server, Dynamic Host Protocol. Why am I forgetting the C? Dynamic Host something protocol. Holy shit. Oh man, it's been a rough day. I'll get back to you on that one. That hands out IP addresses among the network, right? That gives the who am I, the address. Also, you need so we'll just say that this guy's address is now ABCD. You also need to know what you're trying to connect to. So you can either get its IP address or its colloquialism, like its name. Let's just say it's PC5, one of those two. All right, so this guy's ABCDE. And then you need to have a path, right? Your computer needs to find a way in order to get through all of this rigmarole to get not only a path, a solvent path to ABCDE, a reliable path, and preferably the speediest path. So there we go. So hosts access a network, and the first thing they do is they state a request for their identity, right? That's their address. Each non-end device has a role these guys, in transferring information or a location or an address, and they're given identities, right, as well. Information is directed and routed through these intermediary devices to get to the destination. And I'm leaving all of this kind of intentionally anomalous at this point. But this is a rough overall like view of how the network interconnect works. This is how things essentially happen. And we're going to get into detail on all of these, but starting with I need an address, I need to know who I am. Everything else that joins the network is given sorry guys, is given an identity. And these intermediary devices, their jobs are specifically to be able to give information and retain information about routes on how to move through this space in the middle to wherever the destination is. All of this happens in this space. This is what's known as routing. Everything that requires or facilitates a host to be able to talk to something on the network that it shares or on another network that it's somehow connected to is part of the routing service. So, intermediary devices, here we go. What can they do? They can route data more efficiently. That's should not be there. Let's forget that. That's up there. Intermediary devices connect end devices to a network, right? So a switch, its entire job is to make small localized networks of computers and end devices and hosts. And remember where those hosts are located because these guys connect into the switch. If computer A is looking for computer B, anytime it looks for computer B, it's also identifying itself. It's saying, hey, I'm computer A. The switch's job is to remember that, and remember that we'll talk about ports in a moment, but this is where computer A lives in the event that B or C need to get a hold of A. Likewise, this happens against all all devices in the network. They can connect to multiple networks together. We call this an inter-network. You'll note the first part of that word, internet, sounds very familiar. So these devices are called routers. Their entire job is to point other networks to each other and facilitate that traffic. They can also extend a network, these intermediary devices. They can route data more efficiently. That's where that belongs. Regenerate, retransmit communication signals. One of the things that we're looking at time. I got some time. Why? Sorry, I'm trying to get my pad out for you guys. That's fine. Oops, wrong class. Don't mind me. It's not my first time, I swear, guys. So one of the things that makes network devices extremely impressive is that essentially all information that we're getting or sending is ones and zeros. We call these bits. We'll get into this in a moment. This is all data, all information, no matter where we're looking. If you're looking at something like an old school device called a hub, its job was to spit out the exact same string of ones and zeros in all directions to anybody that might be pertinent to, which seems kind of wasteful, but kind of cool to some degree. But also what it did was it stopped the degrade of data as it traveled over wires. What we're looking at is a physical medium, right? We've got a wire that's made out of copper, and it's got electrical signals in the form of a sine wave or a square wave. So here's a 1, there's a 0, there's a 1. My pen stopped working. That's fantastic. All right, everything stopped working. Anyway, it would fight the degradation of physical medium and electricity just being lost in the system, filled with noise, in order to make that information, that data, propagate in almost all directions. There's a lot that goes on besides just sending information, sending datagrams and packets to the right direction. Just those constructs of the network. They actually ensure the integrity of the actual messaging all the way down to the bit level. Why is this not working? Yeah. All right. So we're not using the tablet for the rest of the meeting. That sounds fun. That's all right. My drawings suck anyway. You can tell me. Um, they notify other devices about erroneous collisions, right? We've got literal ones and zeros. We have electrical pulses moving through the network. Everybody's talking at once. They run into each other. We've got these errors, this erroneous happenstance where there should be a 1 and there's a 0, or there should be a 1 and there's nothing. So these devices mitigate those. Um, they direct data along pathways if there's a failure. Let's say this router fails and this was the fastest route. Well, they'll autonomously reroute into a way that works better, that allows the network communication to continue. They can also classify direct messaging according to priority. An example would be something like voice over IP, or maybe you're doing your Netflix binge, right? It might not be important that your email gets to you in a timely fashion within the span of like 5 seconds, but I'll be damn sure I'm gonna be pissed if I'm watching Loki and I see a loading screen for more than a second and a half. It's the end of the world, right? So it's the job of these devices to make sure, okay, this I'm going to use a term that you're not familiar with, but that's okay. This is a UDP packet. Its job is not to be accurate. Its job is to get there fast. It's got information. This thing has got Captain America on it. It's going full speed. This is a work email. Eh, you know, it'll get there eventually. Whether I get that work email now or 500 milliseconds from now is not a big deal. But a frame of my favorite TV show or favorite movie is a big deal. Or voice over IP, something like that. So that. Um, and then also these devices, at some level or some degree, can deny or permit the flow of data based on the security settings, right? So we can start creating security infrastructure by planning our networks well. And we'll get into that. Okay, so we talked a lot about these intermediary devices. We spent a whole bunch of time on hosts. And I think the only thing we really haven't got into is that fascia, that connective tissue. And that comes in a few different flavors. But it's something that CCNA goes light on for some reason. I think it's because the expectation is you're going to get this in like A plus or a more fundamental computer or cabling class. But I want to draw some distinctions here. So uh, there are some facets to choosing your media, right? Like media would be considered that connective tissue between your devices, your intermediary devices, as well as your endpoints, right? How reliable is it? What are the environmental standards that can hold up to? How fast is the medium? How robust is it? What kind of bend? What kind of physical constraints? Where will it work and in what environments will it not work? Those are all things that help us. What kind of security standards? Those are all things that help us choose our media. But really, when it comes down to it, we've got a couple different decisions here. We've got what's called copper. This is our Cat5 or Cat5e or Cat6. This is network cable, right? Stranded pair, which is meant to offset interference between electrical current moving through a copper wire, a conductive wire. So we call this the 802 standard. Everything that's in uh, so the Institute of Electrical and Electronics and Engineers, they are an organization that creates standardizations for the way that anything essentially electrical and a fundamental component to industry or society works. They create standards, right? They create, that's the reason why we have 120 volt standards or 220 or 240 in Europe, things of that nature. The reason why plugs are standardized shapes, the way certain materials can be used in wires, and they're the ones that create standards. So the 802 standard is specifically speaking to what's known as LAN and MAN technology, local area network and metro area network, MAN, MAN. Um, so 802 is the standard for connectivity for physical media, and there are some substandards. So 802.3 specifically about copper wire. 802.3d is a substandard of 802.3 is specifically about fiber optic. And then I'm sure you're familiar with 802.11, which is wireless transmission, right? That's high fidelity radio waves. You guys might be familiar with Bluetooth, right? Bluetooth speakers, Bluetooth connectivity. That's 802.15, I believe. So this organization, IEEE, creates the standards for these ones, right? And these standards, not only do they have physical constraints for the devices themselves on how they're supposed to react and behave, but um, they also have the methods for which these deal with failure, right? So there's something called, you don't need to know this for any tests or anything, and I'm pretty positive it's not on any CCNA certification question, but CSMA stands for Carrier Sense Multiple Access. The idea that this line, this wire, is a carrier, and the devices that attach to it can sense multiple access, right? Multiple connections moving through a wire on a network at any given time. So CSMACD is carrier sense multiple access, a wire that has multiple uses or multiple people using it at one time. And the CD, collision detection, right? We have to have a standard for how these wires connect to network cards. The network cards have a timing element to make sure, okay, you're talking right now, I'm talking. Everything that's in this cadence is from you as a computer. Everything that's coming from this cadence is coming from you as a switch, and how those play well with each other. But also, let's say we screw it up and there's a collision. How do we reset and we get back to normal, right? How do we figure out how to get back to a baseline and start communicating again? So that within the standards for 802, there's this CSMA, Carrier Sense Multiple Access Collision Detection. It's a standard on how we deal with communicating in multiple access environments. Now, when you look at the wireless section, we have CSMA, which is still Carrier Sense Multiple Access. Only this time the medium is the air, right? It's the airwaves. But now we have CA, not CD. So it's not collision detection, it's collision avoidance. How do we make information elevated and energized in the air, not run into each other, and you can have multiple antennas working in the same space. So they don't. There's not a lot of highlighting in the curriculum about network media and specifically this stuff, but I wanted you to know that stuff. It's important to know how these underpinnings work. Good rule of thumb: copper's cheap, copper's readily available, copper's pretty damn quick by comparison to what it used to be. The standard network jack is something that's instituted by the IEEE, and we use it everywhere. Are we going to move away from copper? Eventually, but probably not. It's going to be damn hard. Are we so steeped in our infrastructure? Fiber optic, fiber is great. Fiber is fast. It literally moves at the speed of light. It's pulses of light that move through an optical or glass wire. Doesn't get any faster than that. But it's goddamn expensive. It's really difficult to find technicians that can terminate it well. Um, there are limitations to how a wire can bend when it has to bounce light through a glass tube. There's all kinds of stuff, right? Wireless seems like a great option. You know, it's pretty consistent. It's not as fast as copper. It's definitely not as fast as fiber optic, but it can get you to places where maybe you can't get infrastructure or wires to reach to. There's a pro. A con is wireless safe? Me, I say no. Is there anything like even with the best encryption standards, I don't trust anything that I don't need to on wireless, you know? Additionally, if you're in a cement building with like kind of like a lead wall or you're behind a refrigerator, our radio signal is going to be able to bounce off and have the same fidelity, you know, that you would if you could run a straight cable through? No. So all of these media, they're called media. I'll call them medium because that's what the impulses, the electrons or the wires or the signals are flying off of. All these mediums have pros and cons. And it's going to be your job as network engineers, network architects, IT infrastructure specialists to figure out and understand which is the right tool for the right job. Any questions on any of that stuff so far? I got way deeper into that than I expected to. Here's a list, in case you're wondering, excuse me, of all the 802 series, the LAN and MAN standards. And you'll see a lot of them are actually disbanded, right? So token bus. Back in the day, we used to have computers where the networks all were interlinked. You need two network cards or NICs that were in a line going all the way down the run. And in order to get your computer to talk to another computer, it had to have what's called a token. It says, hey, I've got the conch, you know, I can talk. Here's my token and here's my data. And if your computer was 4 computers away from where it needed to be, it would send the token and the data through 4 different computers till it finally got to where it wanted to be. And if you had a reply, it had to go through X number of computers to get back. And if you had to respond to that reply, then you needed the token to go through. It was a terrible situation, and we're done with it, so that's good. So this is actually a good place to see how far we've come as, you know, a an organization, as a group of individuals who are trying to get high order communications. And you can see the stuff that's active is stuff that we're currently using, and that's what's disbanded is stuff that's gone. So there you go. Now I'm curious, what the hell was I right on Bluetooth? Yeah, 15.1. Okay. Okay, network representation. This is something you don't have to worry about getting caught up on because you were going to see this from here on out. I mean, I'm going to stop talking about doodles and like drawings, and we're going to be using these symbols because net engineers and architects, they need these universal symbols to describe their plans and topologies, right? It's like a blueprint. Um, that's these guys right here. And this is just a handful of them. And you're not going to use all of these, I'll be honest, but they represent the different devices, right? The different roles, and also they help inform the orientation in a network. So somebody can see, who can see this, it's not too small. Somebody give me an example of an end device.
Workstation sun.
There you go, exactly, perfect. Yeah, it's pretty much starting from this laptop all the way down to file application server is could be considered an end device. I've never put a monitor on a network map or topology in my life. That's interesting, but okay. Um, so you can represent the media as well on these topologies to give some scope to your network so that you can start communicating the plan or somebody can communicate the plan to you. These diagrams, They're intended to give you the big picture. And this is what we're going to be typically working off of from here on out. You'll have a, a pretty easy go of it because we'll be using Packet Tracer for most of it. So you won't have to remember, what these symbols are, but you're just gonna pick up on them because we're gonna be using them left and right. I'll tell you right now, what you'll be using most frequently is router. It's this little tuna can looking guy here. Switch, obviously end devices. This says firewall, but you'll infrequently see this in an enterprise environment. Typically, what you'll see is something that looks like this, where it says firewall services module. It'll show a firewall connected to another device. There's another, where it is. Here we go. Route switch processor. This is so misleading. We call these multi-layer switches. They're devices that can do both routing, which is connecting computers through multiple networks, and switching, which is connecting computers within their own LAN or local area networks. So this device right here is just going to be called a multi-layer switch. And I think other than that, other stuff is deprecated or it's not worth knowing for a while. Network cloud. That's going to be representative of the internet and like off-site, off-premises devices. Uh, this right here, this is a multi-level switch. This guy. Bridges don't exist anymore. If you see one in a workshop or workspace, burn it. Let's see, hubs. I think I saw a hub someplace. Yeah, small hub. If you see one, burn it. You don't want to work there. Uh, Bridges are what switches used to be known as. They would bridge devices between a network. That was before when we're coming out of that token topology, that ring situation I was telling you about. So switches were originally called multi-port bridges, and now we just turn them into switching because they switch information packets towards one another. Um, Hubs are a terrible waste of network allocation. Everything that goes into one port would also be multiplied and come out the other port. So it would just create a lot of backscatter on the network, a lot of wasted receiving and send signals and requests for more information. Hubs have been done away with. They're the predecessor to what a switch is now. Far more intelligent, far more specific. So that's what I'm saying. If you see a bridge or a hub, it's not even worth looking at. And of course, anytime you see a line, it's meant to indicate physical medium like copper. These little lightning bolts are WAN media, so typically console or another type of cable, which we'll get into more. And then this little DNA strand looking thing, that just means wireless, which is silly because wireless is everywhere, but they have to point it towards something. Okay, so this is what it's going to look like when you're actually in Packet Tracer, and you're going to be able to tell a lot about your network just from this kind of pseudo representation of a network map or topology. Like just off of this alone, I can see that there's 1, 2, 3, 4, 5. I see 5 networks, two, let's see, 5 intermediary devices, 2 intermediary networks. I see 1 router that's not appropriately connected, and I can see what the connecting device IP address is. And that's just off of looking at this really quickly. So as we get into this, you're going to see that these are more than just a diagram, a layout of what the network looks like. These are going to become kind of roadmaps to how the network was drawn out, how it was intended to work, and what kind of fail-safes were built into it. Also, you'll see by the time we get to the end of this class, you'll see that this right here, this situation with these 3 routers, that's a piss poor job. Somebody's not doing it right. Let's see what else I can figure out from this. This is kind of an interesting exercise. So these symbols right here, these typically are indicative of a server. If I were to take a guess, I would say that this server's job is to offer up resources specifically to this network. So it probably offers that DHCP service I was talking about. It tells these computers what their IP address is, and it probably does what's called DNS, if you're familiar with that from A+, domain name services. It gives it its colloquial name. It will replace this IP address, like 192.168.1.10, with PC2. So when you start to see more of these and become frequently aware of how much information is kind of embedded within these guys. All right. Since we're talking about kind of the fascia, the connective tissue, we should probably talk about specifically how that's connected. So you guys have probably all gone through A+, so you know you're familiar with the term NIC, right? Network interface card. Anybody not familiar with that? So this is the actual device that's plugged into your computer, that goes into your motherboard, the south bridge, that receives data and emits data onto the network. So the NIC, or the network interface card, is that component. It's connected into the motherboard of your computer in the south bridge. It's got its own special channel now. Newer motherboards have their own channels specifically to help deal with network traffic and route them to the north bridge so that the processor can do work on them. The NIC has a physical port, which is it's a connector or an outlet. Actually, let's just do that. There we go. Uh, It's a port in which the medium connects to. So if this is an Ethernet NIC, an Ethernet network card, there are fiber NICs, there are console NICs, there are all kinds of different network cards. This one is specific for Ethernet, for copper medium. So this right here is the physical port. You're also going to hear the terminology, especially in the shop, about an interface. CCNA uses the term port and interface interchangeably, but the certification does it the right way and doesn't use those terms interchangeably. When you're for those of you that are already, working in IT, typically an interface is what's considered a logical connection. A port is a physical connection which you plug a wire into. An interface is a logical connection in which you configure. So if you're working with a switch or a router, you can plug your cable into the port, but when you're in the command line and you're configuring your router, you're configuring the interface. So the curriculum that Cisco gives us, it interchanges physical port and interface. I say interfaces are something configurable, something logical, something that software interacts with. The port is something that's physical. Oh yeah, I made a note that they use port and interface interchangeably. Any questions about that? I know the idea of like a logical port or a logical connection seems a little shady and gray, but we'll get to it in a bit. Before we're done, I want to talk about a couple things really quickly. Topologies. Um, Topologies are documenting the layout, kind of like we were just looking at, a visual map of how the network is connected. But if you go to a job site and you don't have a topology, it's a bad job site. If there's no network map, there's a bad job site. Can somebody take a look at these two guys? These are two different topologies. They have two different purposes. Can you point out the differences between the top left one and the bottom right one?
Top left one shows where the servers are, where each computer is. The bottom right one doesn't. It just kind of generalizes where the IP addresses are.
Yeah,
Physical and logical.
exactly. You guys are both spot on. This is going to open up that port versus logical interface thing in a second. So Jesse, Mo, you're both right. This first one is a physical topology. This is telling you where devices are physically, not so much how they're connected, but where they fit in orientation to the organizational hierarchy, right? You can tell, okay, I got my internet. It's going to come into the server room, and it comes in through router 1. Router 1 is connected to a switch. These switches are going to identify the different networks within our organization. The logical topology is going to be a little different. It looks the same as far as the layout goes, but see here, right here, there's a G0/0, G1/1, FA0/1. This is the difference between interfaces and ports. Like, here's a switch. You can say you plugged in to port 1 or port 15, but you've plugged into interface fast Ethernet 01, right? So it's the first card slot, the second port. That would be the same as saying I'm in port 2. So this FA02, FA01, these are the interfaces. This is how the device itself identifies the physical connection that a cable is getting plugged into. This also is informing us of what the network archetype looks like. This is a 192.168.10 network. So everything, this web server, email server, and file server are on this one network. This is probably a floor. This is the 100 network. This is the 101 network, and this is the 102 network. We can say you can see exactly which interfaces and which devices and how they're connected in the overall organization. They both have their purpose and their role. Physical is for, you're going to use that when you're, as a tech, if you're trying to troubleshoot a device and trying to figure out where it is, especially if they keep archived devices that should have been brought out of the network room and they're still for some reason they're still racked. This will help you figure out that stuff. This is when you've done with the physical component, the kinesthetic component, and you're back at your desk and you're trying to configure the devices so that you can do, port forwarding or switching or do some kind of security appliance work. Both have their purpose, both helpful, both two different purposes though. Any questions on this stuff right here?
Is it normal to have both of them at a location? Or is it normal to have just one or the other, depending on who the tech is or IT guy is?
It really depends. Typically, you'll see the logical topology is a must, but if you are in a shop where they separate configuration versus technician, you'll see the technicians have the physical topology map. Actually, they'll have the IP map, but the interfaces aren't so much a big deal for them. Whereas the network admins will probably have the topology map. They don't need to know where the equipment is physically racked. Let's say switch 1 goes down, they're like, hey, I need you to take off switch 1 and, replace it with another switch. The technician will go in there, unrack switch 1, put it back from rack 1, shelf 2, and then plug it in. And then the administrator will go and configure the ports with the replacement switch 1 so it works as it did before.
Okay.
My personal preference, I like to see it all. When I label my network devices, I actually label them with physical locations as well, just so somebody behind me can finish the job if something happens to me if I get hit by a bus. Okay. Networks of many sizes. I know this is dry, guys, but after we get out of one, module 1 and into 2, we start kicking off, and we spend most of our time actually configuring. So hang in there for this next till Thursday, I guess. Okay, networks of many sizes. What you'll need to know as far as the certification is considered is that there are three overarching types of network. There's your home network. Home networks are typically, shared devices. They could be peer-to-peer. There's not network appliances. Usually the network type, I should say almost all the time, the network type is identified by how many hosts it serves. Home network, I mean, have 15 devices maybe, your iPhone, your iPad, a couple of tablets or laptops, your home desktop, and then whatever, anything else that might come onto your wireless. SOHO, small office, home office, those usually the only thing that articulates a SOHO is that they have an additional device for a specific purpose, right? Like when you're in a home network, you keep your files on your computer, your spouse keeps their files on their computer, your kids keep their files on their devices. It's very, very much that situation. A SOHO, you start to pull resources into a singular device for a singular purpose. So that's why we have this NAS here, this network attached storage, and things that need to get stored, they're not stored on your computer, they're stored on the network attached storage. We have a specific device with a specific purpose, which turns this into a small office, home office situation. And then from there on, it just escalates. That's when you start having managed switches, managed routers, managed devices that are intended to control and curtail traffic, coordinate and configure traffic, and separate devices. This is also where we get internetworks, right? We have routers that can switch up between or designate differences in networks. Maybe one floor will have its own network, one department will have its own network. You need things like host authentication tools. You have specific network roles like DHCP, DNS, file server, web server, FTP, which stands for File Transfer Protocol. That's when you start getting into out of the small office, home office, and you start getting into enterprise environments, which is essentially what this class is going to be gearing you up for. Okay, almost done for the evening. Sorry, guys, I took you over 6:05 here. LANs and WANs. LANs are, of course, local area networks. WANs are wide area networks. LANs represent small geographic areas, right? We're talking about a floor. We're talking about a department. We're talking about a residence, right? Your house would be considered a LAN. Typically, they're co-located in the same area. There's not a lot of need for anything intense. In this map right here, we can identify these guys as being the LANs. This router is the wall. This is the edge. We call this an edge device that tells us where we are at the boundary of our local area network. The same one for over here. Hey, look, I fixed the router situation. And then here's another network. Now, typically, but not always, you'll see that these local area networks share what's called the same IP schema, right? They're the same neighborhood, they're the same hood as far as addresses go. Like you might live on 123 Main Street, your neighbor's on 125 Main Street, your neighbor across the street is 126 Main Street. You're all 12X, That's what your LAN is going to look like. Very equidistant as far as your IP address range. You go over here to another LAN, they're guaranteed, if it's in the same organization separated by network boundaries, not to have the exact same IP address schema. They might be like 192.168.3 or 10.10.5 or something completely different. We'll learn about this later, but all of these networks are private network address schemes. So you can have another 192.168.1.10 in another organization in another building. But that addressing scheme has no impact on yours. There's no way to route information from there to you without specific protocols in play. The job of these networks are to be localized, to be privatized. Let's see. And then, of course, we have WANs. So again, here's a picture of the LAN. Here's a home office. Here is a branch, which would be considered one network. Maybe it's a very small branch. Who knows? This is central. They got a lot of appliances for one network, but hey, whatever. I mean, you can see here's the router. That's the LAN, the local area network boundary. This is an edge device. Here's where it starts to connect to cloud devices or it connects to the internet. That's wide area network. I'm trying to think if there's anything that you need to know as far as certification worthy. LANs are administered by one person or not administered at all. They're just kind of free flowing, where WANs typically have entire infrastructure, right? They have them, they're managed by service providers, they're managed by organizations. Their characteristics justify that much. These guys, you know, you don't need a whole team to be able to manage this. And then the other thing that I'd want to bring up is MANs. Mentioned it once before, metro area networks. And those are, if you've been to Atlanta recently, where they have an entire citywide network that you can connect to. It's not like, I don't know how to describe it. It's not like a free internet. It's an actual pervasive network that extends through the entire boundary of the city, and you can connect to that city in different areas and get different resources, different online resources based on your wireless connection. So that's becoming more prevalent. You'll see that. I think St. Louis has one too. Los Angeles will probably get one. Santa Barbara will probably get one. So we'll start to see these pop up more. And then also, the internet is a WAN. It's a interconnected WAN LAN. It's a series of these pervasive WANs and LANs. And that was the intent, right? From 1969, the DARPA initiative was create a network of communication that could withstand a nuclear, catastrophe. Something that would be a self-healing network. If something went down, there would be another, link in the chain that would reroute communication somehow, some way. So they did it. The internet is not owned by any individual, or a group. There's organizations that kind of oversee aspects and protocols. We mentioned the IEEE, the Internet Engineering Task Force, ICANN, which is the Internet. Ooh, this is going to screw me up. Corporation for Assigned Names and Numbers. Those are the ones that hand out DSN at the very corporate level and global IP addresses, high level IP addresses. That's an organization that does that, but it's not owned by any one person. Elon Musk, regardless of what he feels or believes, cannot buy the internet. And then last thing we're going to talk about, intranets versus extranets. And I made a distinction between the curriculum here, even though it's not in the certification. I feel like there needs to be a difference, a designation between network, your local area network, your intranet, your extranet, and the internet. So they say in the text, internet, that's your global access. Extranet is for collaborators of like your business. So let's say you own, you know, furrydogs.com. I don't know where that came from. You have an internal network for resources within your organization. If you have a authenticated login, you can go to your intranet and you can get those resources. Let's say you have logistics partners or collaborators or other stakeholders. They have a smaller subset of resources that they can access if they have authentication, and that's connected to the extranet. But if you're in your network or you're in your place of work and you have a network cable that's connected to the wall and you have a device and you plug it in, you are now on your network. You probably have internet access. You probably can't access network resources like share drives and such or printers without having authentication. You definitely can't access the intranet without having authentication, but there's a very distinct line between intranet and network. If you take your device and a plug and you plug into a jack at your work, chances are you'll get internet and you'll be on the network. You'll be given an IP address by a router. Some examples that the book or the online text mentions about extranets: a company that's providing access to outside suppliers and contractors, that would be the extranet, right? A hospital making a booking system to doctors so they can make appointments for their patients, that's an extranet. You see like portals, online portals for customers and such, that's connected via an extranet. It's an external, publicly accessible interface or a methodology to connect to resources, but it's very limited in scope, and chances are you need authentication of some kind. So that's it for 1.44. I will do a follow-up video, which I will keep to under 20 minutes, I promise, and that will get us out of module one, and we'll be in module two by next week, and we'll be ready to rock. Is anybody not able to access their Net Academy or their Packet Tracer? Because we're going to be starting to use Packet Tracer heavily as we get into the next fundamentals. Most of our lectures will be, all right, here's 10 minutes of us talking. Now let's get into some Packet Tracer, and I'll be yammering a little bit while you guys do your thing. Good on Packet Tracer? Excellent. Cool. If
I do
anybody's...
have a question.
Yes, please.
So right now I'm on my work computer, but I also do work on my home computer. Does it matter if I have a two computers?
No, not at
Good
all.
question.
Yeah, it's a great question. In fact, you know what I'm going to do is I'm going to put the Packet Tracer installation file on the Canvas shell. You just need to have internet connectivity the one time and say stay logged in for 3 months, and you should be fine. Great question,
Okay.
Mo.
Yeah, I had a kind of follow-up question to that too, because I just was using a company computer and I just replaced it with another company computer. And I noticed I lost my bookmarks when I was in the Netech. I was like, does it affect me like from what the stuff I was already reading? And then when I got my new computer, I went back into Netech and I was like, oh, where's all my bookmarks? So I just skipped to where I went.
Okay, that's
And
interesting. I thought that your bookmarks were connected to your account,
yeah, that's
um,
what I thought too.
not through a local like cookie
Browsers.
or anything.
Uh-huh.
Yeah. So that's interesting.
And my other question was when I do launch Packet Tracer and I download one of those like Packet Tracer files and it opens. I don't know if Moses have seen that but I get this like profile prompt and it has guest. If I put my name and email address, it tells me your activity is going to reset.
If if you log in as a guest, you can only save 3 times and your activity resets. If you do a full login where you use whatever your email address is for the Net Academy logon and then
Yeah,
your password, and then usually what I do is I say check to keep me logged in for 3 months. Um,
yeah, yeah. So when I launched Packet Tracer, I logged in with my Netacad login. But when I launched the Packet Tracer file, it comes up with a little profile window. I was gonna send you a print screen, but I was like,
well, if you get a chance, send me a print screen and I'll reach out to Netacad and see if I can figure out what's going on with
okay,
that. I haven't heard of that before.
okay.
Yeah. Huh. Interesting. And it's really interesting about the bookmarks too, because that was the claim to fame, right? It's a platform as a service. It's supposed to be a
Yeah.
yeah.
I was kind of got nervous. I was like, oh, do I gotta start over?
I don't know.
Did my session stop recording?
Nope. I think you should be good. All right. Fair enough. Okay. Good. Great questions all around. Anything else?
I have a question.
Yes, please.
Were we supposed to get an email to log into Net Academy?
Yeah, you should have. Let's take a look here. Have you not received an email for Net Academy?
I have not.
All right. Let's take a gander. Let me stop recording.